Hi, this presentation will walk through how electrons are being filled in an orbital, especially for the first 36 elements using SPDF notation. So now, first of all, we need to be able to relate the space where we can find the highest probability of electrons is called orbitals. And altogether, out of 118 elements in the periodic table, there are 4 different types of orbitals, and they are all given and represented by using different letters known as S, P, D, and F. Now, they all have 4 different letters that denotes the shape of the orbitals and their location in an atom. Now, in detail, if we're looking at S, the, the shape for S orbital is sphere, okay, which occur at the lowest energy level, in other words, closest to the nucleus. Whereas the P orbital has a dumbbell shape, and it comes with 3 different directions as px in axis, x-axis, and y along the y-axis, and z along the z-axis. So as the energy level increases means when the atomic radius increases, the space to accommodate electrons increases as well, and that gives a larger space to accommodate and arises D and F. Now the next slide gives you an idea how electrons are being filled from the lowest energy level by looking at their shape. Let's look at this video. So this is where we start from the lowest energy level as S orbital, spherical in shape, right from the center of the atom. As the radius increases in 3 dimensions, you could see electrons now can be filled in dumbbell shape with 3 different axes as X, Y, and Z. They overlap one another when it started from the S, then followed by larger orbital known as D orbital with different shapes and sizes. So you can see based on different orientation and dimension, they are given different level. So the importance for this video is to be able to see that electrons are filled from the lowest energy level from S, then P. As the radius increases, we are able to fill in electrons to the D orbital, okay, then F. I'm going to play the video up to here. However, at your free time, you can go to the same PowerPoint to go through the thorough video on SPDF. So now let's look at the detail how S orbital can change from lowest energy level from 1s, 2s, and 3s. Now, it has a letter of S because it's spherical and sharp, and each orbitals can only accommodate up to the maximum of 2 electrons. So although they have different sizes of S orbital, they only can accommodate up to 2 electrons per orbital. As the radius increases, we can see at second energy level, we have px that can also accommodate to the maximum of 2 electrons. So when you write electron arrangement, as we write 2p, you will be writing 2px, 2py, and 2pz. So meaning you say I'm going to fill in electron from the x, y, z, x, y, z, then followed by the second half as x, y, z in the opposite direction as shown in the picture. Now, by drawing this half arrow that give you an idea how electrons are being arranged in opposite spin. As we move on to d orbitals, as you can see, there are maximum of 5 orbitals which means we can fill up to the maximum of 10 electrons from 5d suborbitals. And this only occur at energy level 3. Now, energy level 3 in a simpler word means from period 3 elements onwards. So as the atomic size increases down a group in periodic table, we expect the atomic size to be able to accommodate more and more electrons. And when it comes to the lanthanides and actinides, that is where we will have all variety or different sizes of shape with a total of 14 electrons, as we have 7 different types of orbitals. Now again, it only starts from energy level 4, okay, for f orbitals. Now the summary for SPDF is, okay, s orbital is only found on the left hand side of the periodic table. So, okay, say if you are given element X with 11 as a proton number, so okay, you're going to start writing or fill in electrons from the lowest energy level as 1s2, 2s2, then 2p6 as a maximum for each of these orbitals, then followed by the 11 orbitals as 3s1. Now, the last orbitals written will be known as the valence orbital, and these 3s1 give you clue for the exact position of these elements in terms of group number and also period number. Now we can obtain the group number just by looking at the superscript number written on top. So if it is end with 1, that will be group 1. Whereas period number can be obtained from the digits written, okay, before the orbital, and in this case, that's period 3. So from here, we can actually tell the exact location. Now this, okay, S orbitals refer to group 1 and 2, whereas P refer to group 13 to 18. Say we have P, 3P1, 3P, okay, 3PX1, 3PX 3py1, 3pz1, then followed by 3px2, 3py2, and 3pz2, with a total of 3p6 for the last one. Now again, okay, the valence orbital is 3s2, 3p6, so the group will be 2 plus 6 plus 10 groups in the middle as D block. So that will give you group number as group 18. Okay, and the period number is denoted by the digits written. The bigger digits written as 3, that means it comes from period 3. I hope this give you illusion and make sense that by writing electron arrangement, we can tell the exact location, and from there we can determine their chemical property. Now, these are some of the rules that you need to bear in mind, especially when you start writing the electrons. And the 3 rules and principle that we're using start from letter A as Aufbau. So Aufbau principle stated that electrons must be filled from the lowest energy level. So this has been what we are doing, starting filling in electron from the lowest energy level as 1s, okay, then followed by 2s. So we don't fill in electron halfway through like 3s or 2p6. So we need to fill in the electron from the lowest energy level. Then Hans rule. Now, one easy way to remember Hans rule is half, okay? And A in Aufbau means the first alphabetical order that gives you an idea that it has to be filled from the lowest energy level. Hans rule, on the other hand, okay, give you illusion on half, okay? So we're going to fill in electron, okay, with parallel spins, means that in p orbitals, when we have px, py, pz, so we have half the electrons in parallel spins. Okay, so they don't pair up before they are singly fielded. Then followed by Pauli exclusion, so P for opposite. So that give you an idea that the electrons must have opposite spin. So when we have the 3 electrons fielded in XYZ, that means the fourth electron will be fielded in the opposite spin denoted by the opposite direction, okay, as in the blue half arrow. And okay, the fifth electron on the PY and PZ. So this gives an idea that okay, it must have the maximum of 2 in the opposite spin. So there are some example right here that shows how electrons are being filled. Okay, starting from the basic you learn at lower um, lower grade. Okay, so you have 1s, 2, 8, 18, and then you have 2 again. So this gives you an idea where does electron come from. Okay, so probably if I show another slide that will give you an idea. First energy level can only have s orbital as it can only accommodate to the maximum of 2 electrons. Okay, so we have 1s to start with. Then second energy level. Okay, so follow the arrow. We have the s orbital. Okay, this is a sequence as this as 1s, 2s, then followed by 2p. So follow the arrow as we cut to 2p before reaching to 3s. So this is the third energy level that's up as 3p and 3d. So you can see 3s followed by 3p, okay, then 4s. Now 4s come before 3d because an empty 4s orbital has lower energy level than 3d. However, the energy level of 4s will quickly rise higher than 3d when 4s is being filled with electron. In filling in electron, there are some exceptional rules, especially when it comes to transition for the number of 24 and 29. So 24 means we will have, okay, if we use the usual way of filling electron, we should have 3d4 and 4s2. Okay. However, based on Hans rule, the electron need to be filled, okay, in singly fielded as half fielded configuration, okay, half fielded configuration, which is more stable than 3d4. So meaning to say, to be more stable in chromium, there's one electron that come from 4s2 to be shared and donated to 3d, and that give 3d5. Okay, so which means the final configuration is 3d5 and 4s1. Now, this is the sequence in writing electron arrangement. However, once you have written the electron, you need to put the 4s further away from 3d to help you and also to give you a better sequence in removing of electron, especially when the element form ions. Now, another exceptional rule may apply to copper, okay, with 3d10, okay, and 4s1. Now, again, 3d9 in this case is less stable. Therefore, one electron will be obtained from 4s to form 3d10. So here's a summary for the first 30 elements, and I hope you enjoy this video and makes sense to you. And okay, have a look at some of the extra notes on how you write using shorthand expression, yeah, where heliums represent, yeah, 1s2, neon represent first 10, argon represent 18. And do not forget to subscribe and also use the worksheet given to fill in and practice filling in electron. I hope you enjoy this video.